we'll look first at a cross-sectional view of the vertebral canal. This is a cut through the 6th thoracic vertebra. Here's the spinal cord. It only partway fills the vertebral canal. On each side there are 2 lines of nerve filaments, one arising from the ventral aspect and one from the dorsal aspect of the cord. These filaments form the spinal nerves, as we'll see in a minute. The spinal cord lies within this strong protective layer, the dura. The dura is lined on the inside by a loosely attached membrane, the arachnoid. The cord is covered on the outside by a firmly attached membrane, the pia. The space between the arachnoid and the pia is called the subarachnoid space. In life, it's filled with cerebrospinal fluid. The space between the dura and the wall of the vertebral canal is called the epidural space. It's filled with fat, loose connective tissue, and blood vessels. To see the contents of the vertebral canal from end to end, we'll take a look from behind at a dissection in which all the laminae have been divided along these lines and removed. Here's the sacrum. Here's the base of the skull. The tissues that occupy the epidural space have been removed to give us a clear look at the dura. This is the dura. The sleeve of dura is called the dural sac. It's open at the top end and closed at the bottom. Here, at the base of the skull, the dural sac passes through the foramen magnum, becoming continuous with the layer of dura that surrounds the brain. At the bottom end, within the vertebral canal of the sacrum, the dural sac tapers down to a point at the level of the second sacral segment. To look at the spinal cord, we'll divide the dura in the midline and lay it aside. Here's the spinal cord. These are nerve roots. We'll look at them in a minute. The cord is attached to the dura by a series of fine triangular ligaments, the denticulate ligaments. To see how the spinal nerves arise, we'll go up to the cervical region. The denticulate ligaments have been divided. Each spinal nerve arises from a small bundle of dorsal filaments, which unite to form the dorsal sensory root of the nerve, and a similar bundle of ventral filaments, which unite to form the ventral motor root. In the cervical region, the nerve roots follow a slightly oblique downward course. In the thoracic region, their course becomes more oblique. Here, right at the lower end of the spinal cord, this continuous line of nerve filaments gives rise to a large number of nerve roots, which run vertically downwards, almost hiding the very end of the cord, which is here. Below this point, the dural sac is occupied not by the cord, but by this leash of vertically running lumbar and sacral nerve roots, the cauda equina. The nerve roots leave the vertebral canal, 2 at a time, all the way down to the lower end of the sacrum. Here are the roots of the nerve, leaving the dural sac. Here's the nerve, emerging from the intervertebral foramen. To see the whole course of the nerve, we need to remove this part of the vertebra. Here's the dorsal root of the nerve. Here's the ventral root. The sleeve of dura that surrounds the converging nerve roots merges with the outer layer of the spinal nerve. This thickening at the very beginning of the spinal nerve is the dorsal root ganglion. The spinal nerve passes forward and laterally to emerge from the intervertebral foramen. To To see that more clearly, we'll go back to the preceding stage of the dissection. As the spinal nerve emerges, it divides into this small posterior primary ramus and this much larger anterior primary ramus. The posterior primary rami of the spinal nerves pass backward to supply the muscles and skin on the back of the body. The anterior rami pass forward and laterally to supply all the rest of the body. This anterior ramus is an unusually large one. Here's the brain. Much the largest part of the brain is the cerebrum. The cerebrum is partly divided in the midline into two cerebral hemispheres. Below the cerebrum, and separate from it, is the smaller cerebellum. The cerebrum and the cerebellum both grow out of the brainstem. The brainstem becomes continuous below with the spinal cord. The brain is contained within the cranial cavity. This part of the cerebrum, the frontal lobe, occupies the anterior cranial fossa. This part, the temporal lobe, occupies the middle cranial fossa. The posterior cranial fossa contains the cerebellum and the brainstem. Here's the cerebrum with the brainstem attached and the cerebellum removed. The functions of the cerebrum include the senses of vision, hearing, smell, touch, and spatial perception, and also speech and language, memory, thought, and voluntary action. The cerebrum is formed mainly by the two cerebral hemispheres. These are separated in the midline by the falx, which occupies this longitudinal cerebral fissure. Though they look hemispherical from in front, the shape of each cerebral hemisphere is more complex when seen from the side. In front, this part, the frontal lobe, occupies the anterior cranial fossa. This part below, the temporal lobe, occupies the middle cranial fossa. This part behind, the occipital lobe, lies above the tentorium. Here are the brainstem and the cerebellum together. The main functions of the cerebellum have to do with balance, motor coordination, and the control and monitoring of intentional movements. The cerebellum occupies most of the posterior cranial fossa. The tentorium is just above it. To see the cerebellum better, we'll look at it by itself. The surface of the cerebellum is marked by many parallel fissures, some deeper than others. This deep primary fissure divides the cerebellum into a small anterior lobe and a large posterior lobe. A deep groove on the underside partially divides the cerebellum into two hemispheres. These are joined by this midline mass, the vermis, which extends all the way round from the top to the underside. Here are the divided cerebellar peduncles, the superior one from the midbrain, the inferior one from the medulla, and the middle one. As we've seen, the middle cerebellar peduncle becomes continuous with the pons.